My name is Louise Leong, and I'm the gallery manager of the Mary Porter Cesnon Art Gallery. I'd like to start off with a land acknowledgement for UC Santa Cruz's campus. The land on which we gather is the unceded territory of the Awaswa-speaking UP tribe. The Yamamutsin tribal band, comprised of the descendants of indigenous people taking the missions Santa Cruz and San Juan Bautista during Spanish colonization of the Central Coast, is today working hard to restore traditional stewardship practices on these lands and heal from historical trauma. So we're pleased to welcome back the Center for Genomic Gastronomy, our artists in residence for the third event in Planetary Indigestion, a year-long series of conversations and interventions. The center is an artist-led think tank that has been examining the biotechnologies and biodiversity of human food systems through experiments and public art projects since 2010. They are artists in residence invited to our campus by UC Santa Cruz Genomics Institute and Open Lab Research, which continues their ongoing partnership, bringing interdisciplinary research across the arts and sciences to the public. I also wish to welcome our guests, David, Rob, and Natalie, who are also joining us today. Please drop your questions into the chat throughout the event. And finally, this event is being recorded and will be uploaded to the Cesnon Gallery YouTube channel. So now I'll turn it over to the center now to introduce themselves.
Hello.
Hello tonight from Amsterdam. This is Zach Denfeld calling from Amsterdam.
And I'm Emma Conley, and I'm calling from Portugal.
Thanks for joining. Tonight is session 3 of the Planetary Indigestion series. We're calling it Civilizational Anxiety and Climate, and the big theme is the air is alive. Just to give an overview how tonight's going to work. We're roughly following a recipe that we wrote for making Wildfire Loaf, and we'll tell you what Wildfire Loaf is in just a little bit. But Emma and myself will do a quick introduction, no more than 15 minutes about that research project. And then we'll begin to hear from our special guests, which we'll introduce in a second, in different intervals with lots of moments for Q&A from the audience. I guess, Emma, you might have your eye on the Q&A as we go. But if I miss them, I'll try to keep an eye on it as well.
Yeah, I will.
We'll try to keep it to just about 90 minutes, but if there's burning questions at the end, people want to keep the conversation going, Emma and I will stay on. Likely our guests will have to run and do many of the important things that they're working on, but we can certainly stay on and try to add things. Anything to this slide, Emma?
No, I think that's it.
Okay. Unfortunately, Philip Cruz couldn't join us tonight, but luckily we've gotten to take a look at some of his papers and research, and we'll add a few comments based on that research. But what I'm going to do now is just introduce each of our guests quickly and ask them to name their favorite bread or sandwich that they've had recently or maybe in their whole life, just so you can hear their voice and see their face. So first is David Kaisel of Capay Mills, which is a regional mill that uses regional grains. It's David out there. Yes, favorite sandwich or bread?
There we go. Hopefully I'm back on. I can't quite tell, but hi. Not as exotic as Amsterdam or Portugal. I am in the town park in Esparto, California, Yolo County, the gateway to the beautiful Capay Valley, which is an amazing area. And as Zach is saying, I mean, this is really kind of the heart of the farm to fork movement in a lot of ways, at least in California. And the growers here just, there's 60 plus organic farms and incredible experience and knowledge. My favorite loaf, I like a loaf of bread that tastes like something. You know, my job is introducing people to wheat and the diversity of wheat and the character of wheat. And it's something that's completely absent from commodity milled flour. We never see that. And as soon as you dive into single varieties, whether they're modern or heirlooms or ancient grains, you realize that there's an incredible difference from variety to variety, from field to field, from season to season. And I love bread that highlights those differences. So in other words, bread that's really simple. A plain country miche, sourdough. I do really value sourdough, and we'll go into it at some point. I think that that's the way to make bread. It was for 10,000 years at least. Yeah, so anything that highlights the grain it's made from is exciting to me. That was the first question, wasn't there? Sandwich. I don't know, a BLT, something with tomato, anything with really good tomatoes on it. That was a late discovery to me, and what tomatoes taste like. And I can't get enough of them, especially this time of year.
Thank you. And next we'll introduce Rob Dunn of North Carolina State University, and partly the Sourdough Lab. And that's a big ask to follow up after someone who mills grain for a living, but yeah, bread or sandwich.
Yeah, I'll try to follow up by not answering the question and answering a different question, sort of. So I'll answer the first question, but not the second one. And so I'll answer the two favorite breads. And so the first is, we teamed up with Meyer's Bakery in Copenhagen in Denmark, and we made a sourdough starter based on the microbes from endangered Galapagos plants that were in the botanic garden there. And for a week, that starter had amazing flavors, and then they disappeared and the microbes disappeared. But in that week, that ephemeral bread that was made from that starter was great. And then the second one is that we did a big experiment with bakers where we tried to figure out the extent to which their hand microbes contributed to the microbes in the starter and contributed to the flavor. And so we then tasted, we showed that there was an effect, and then we tasted the breads made by different bakers. And so I liked those breads because in each one you were tasting one of the bakers. So that's mine.
Amazing, thank you. Next we have Natalie Zajac of UCSC's Environmental Art and Social Practice MFA program. And for the purposes of this talk, our citizen science sourdough bread baker. So yes, Natalie, what about you?
Hi, everyone. My favorite bread, I don't think I talked about this yet with you guys, but my favorite bread would be Irish soda bread. I have a very huge sweet tooth and that one's just perfect. And I also talked about one of my favorite restaurants, or I guess chains in the Midwest, which is Potbelly's, and they make a really great Italian sandwich, Italian herb bread. So yeah, that's my guilty pleasure.
Nice, thank you. And actually, the studio was based in Ireland for about 4 years. That's where we originally met Rob many years ago. So lots of soda bread was eaten. Well, we're going to skip Jennifer as well. She's having some technical difficulties right now, but you'll see her pop up, we hope, later in the event. But you got to meet David, Rob, and Natalie and hear their voices, which hopefully you'll primarily be hearing the voices after the first 15-minute intro. So Emma.
Yeah. So we thought we would just introduce ourselves quickly. We are the Center for Genomic Gastronomy, which is an artist-led think tank that examines the biotechnologies and biodiversity of human food systems. We have a mission, which is to map food controversies, prototype alternative culinary futures, and imagine a more just, biodiverse, and beautiful food system. And so we've been working for about 10 years in this project of genomic gastronomy. And the kind of artistic research that we do is shared and disseminated in various ways. So we make publications, books, written pieces. We also do larger like installations, artworks, and full exhibitions. And then we also create more hands-on or participatory events like workshops. And then finally, we also make a lot of recipes and meals that deal more with the like material nature of food and food systems. And then to do this work, we collaborate with lots and lots of different people. So different farmers, chefs, scientists, other artists and designers, hackers, food producers, and much more. So for each project, we're kind of always trying to find the right combination of experts or practitioners to help us kind of realize these different ideas. So tonight's talk is called "The Air is Alive: Civilizational Anxiety and Climate." Did you want to talk about that a little bit, Zach, actually?
Well, if you visited the first session on planetary indigestion many months ago now, we talked about smog tasting and some of our research about the flavor and taste of air pollution. And in some ways, we've continued to build on that research with Wildfire Loaf. In terms of civilizational anxiety, I think we've been attracted to wheat and bread for the last 2 or 3 years for its symbolic meaning in lots of different ways for different cultures and different communities and peoples. And then also its huge importance in the global food system. And, you know, people who, I guess we might get into this a bit tonight, we'll see, but wheat flows are definitely under massive strain because of conflict, increasing prices of chemical inputs, and then you know, attempts to find alternative ways to grow grain. So there is a lot of anxiety about this symbol of civilization.
So this project, or this evening, is based around a project called Wildfire Loaf. And this project is basically a creative research project that aims to taste test and genetically sequence sourdough bread starters made from smoke-tainted wheat in order to trace the connections between wildfires, land use, aerobiology, wheat farming, and bread making. So we've been working on this for...
We'll define aerobiology and smoke taint later. Those are technical terms.
Yes, yeah, we'll get into all of this in a few minutes. And I think we should just say that we've been working on this project for like maybe a year and a half, but it's still in pretty early stages. And so, you know, the project has kind of a goal or a general direction, but it's open to lots of different directions and explorations along the way. And so the way we've been kind of imagining it as a research project is that Wildfire Loaf sits at the intersection between wheat, wildfire, and sourdough bread, and that each of these kind of zones or domains has many interactions between them. So we're dealing with things like taste of place or bioregionalism, also things like land use and all the implications of that historically, dealing with politics and capitalism, colonialism, and then of course ecology and climate change. And then looking also to the kind of mechanisms of the market and wheat as a commodity, looking at how it's processed, shipped around the world, how it's used as an ingredient. And then finally, what that also means in terms of the sciences around breeding and selection and use of this ingredient. So the project itself is kind of based on this idea of smoke taint. So smoke tainted, and specifically smoke tainted wheat, but smoke taint occurs when a crop is either burnt by wildfire or smoke from a nearby wildfire, or any fire for that matter, travels to the agricultural field and somehow taints or alters the crop. So in this case, you can see a piece of wheat that's been burnt, thoroughly burnt, but it can also just be smoke that has settled in the area of the field for a week or so and is causing some kind of taint or perhaps flavor change to the crop. And we became interested in wheat in general. Actually, about 9 years ago, we visited the USDA grain grading facility in Portland, Oregon. So a lot of wheat is shipped out, is kind of gathered at this port in Portland, and then shipped out to Asia or other parts of the world. But before it's shipped out, it's graded, it's kind of tested and examined, analyzed. And when we went to visit, they were showing us different ways that they would grade or analyze the grains. And one of them was literally just sniffing these samples of the grain with the goal of seeing if there were any COFOs within the grain. And COFO stands for commercially objectionable foreign odor. And so one of these objectionable foreign odors would be smoke taint. And so that's where we started thinking, oh, well, what is smoke taint and how, how does it actually affect, in this case, wheat? And so the next question we started asking was, well, how do wildfires then affect the smell, taste, and texture of wheat and bread? So around
the gestation period of a project is like almost a decade, but for sure that visit left a real impression, being able to go and see these quite mechanical ways that wheat is graded, both shaking machines with like oil and cogs and people smelling. And I think the kind of connection between those activities and these huge silos and understanding the flows of wheat around the world just stuck with us as a studio. And Emma, myself, and Kat, the kind of the three core members, were all there at that day. So it's sort of something we've continued to return to.
And when we started looking into, how is wildfire affecting food or bread, and we were thinking a little bit about, chemically, but also maybe biologically, we came across this kind of new area of study. I think the term was only created around 2017, called pyroaerobiology. And so this is an area of science that looks at the intersection of fire science, microbiology, and smoke science. And what they were realizing was that when a wildfire occurs, a kind of new combination of microbes is released into the air and basically floats in a plume of smoke and can travel and populate other areas. And so there's this kind of microbiological component of wildfires that hadn't really been appreciated or well studied until recently. And then likewise, at the same time, as we're learning about pyrobiology, you see every day in the news these kind of articles about how the wine industry is being put under a lot of pressure because of the wildfires that have been occurring with more prevalence and more severity. And so how are winemakers dealing with this? And so it can be anything from moving vineyards to whole different geographic locations to these kind of adaptation techniques for applying sunscreen type things to your plants, or even new kind of processing techniques to take smoke tainted grapes and actually try to process them into a wine that's still desirable.
So that was our very quick intro, because we wanted to get the guests' voices heard. So now we'll walk through everyone through this sort of conceptual recipe of the wildfire loaf. There's a few different moments: wheat, wildfire, sourdough starter, sourdough, bread, wine, and finally some tasting notes at the end, we hope.
So we'll start with wheat, which is kind of the base of the bread. And we should say, I guess actually before all of this, is that alongside this lecture and the development of this event tonight, we had Jennifer and Natalie on the ground in Santa Cruz making a simulated wildfire loaf. And so part of this will follow their kind of journey in making that loaf. And then part of it is David and Rob's input from a more specialist or expert point of view. So Jennifer bought the wheat from David and Capay Mills. And so we wanted to ask the first question to David. Can you tell us about the Max's Marvel whole grain flour blend that was used in this version of the wildfire loaf? How was it grown, processed, any characteristics, anything you'd like to share about it?
Well, let's see. So much to talk about that you've touched on. Boy, it's really, I can't wait. So the Max's is one of the two blended flours I do. Otherwise, everything is a single varietal flour that I mill. But it's also one of my most popular. The primary wheat in the flour, first of all, I only mill whole grain flours. which makes a significant difference because you're including the bran and germ in the flour. And as you can imagine, the bran's the exterior layer of the wheat kernel. Commercial or commodity flours are sifted in such a way that you lose that, but that's also the part that's going to be most proximate to any, well, let's see, pyroaerobiologicals or smoke. So that's, I would be interested first off, whether whole grains work differently from highly processed grains and flour that you see on the store shelf. Anyway, back to Max's. It's a red wheat forward. The red wheat is called WB9229. Not a very exciting name, but that's how many modern wheats are named. It's developed out of UC Davis. And the distinctive thing about the 9229 is that as a red wheat, as a whole grain flour, it has particularly nice baking characteristics, flavor characteristics, all of that. Red wheats, as the name implies, are darker color than white wheats, and that dark color comes from tannins in the aileron layer, in the outer layer of the wheat kernel. And tannins are bitter. That's same thing that brings out astringency to wine, for example. So anyway, we've got a red wheat forward, and then I use a white wheat called Patwin, which likewise is a modern wheat, also developed by UC Davis. I have 40% or 38% of Patwin, and then I put a little malted rye in there, and I've just recently started experimenting and really enjoying this whole other world of malting, which leads me into the beer world. I won't go down that rabbit hole, but how do you, it's wheat transformed, and all these different ways of taking this this grass that we've been dealing with for so long, and turning it into something different. It's very true, of course, that when people say that beer is liquid bread, they're the same thing.
Maybe this is perfect.
Yeah, go ahead,
the
please
next
do.
question. Lead in well, yeah. Maybe just more, if you wanted to talk more generally about your work around grain diversity and why is that important and how do you get interested in it? Big question.
What fascinates me, and I have a very large dump truck next to me that I'm praying is not going to dump their load right here. Sorry if, okay, anyway, I'll let him do his thing. Diversity, I find diversity is the core of not only flavor, but resilience in terms of agronomic resilience. We not traditional, but modern breeding tends to focus in narrower and narrower on specific attributes of the wheat, mainly disease resistance and yield. Okay, a couple of others get featured. But once upon a time, traditionally, and this is particularly with heirlooms, farmers would pick what grew best in their field for their locality, for their situation, the weather where they are, whether it's Mediterranean climate, a Nordic climate. There's so much diversity there. And different wheats at that time were developed to excel, to place to produce their best performance, picked very specifically for place. And that can change. And then secondarily, traditional growers were looking at application, at use. Is this a wheat that we're going to make pasta out of, for example? Is it a wheat we're going to make breads out of? Or do we use it for pastries, cookies, softer kind of products? And the wheats will have all sorts of variability within those other broader categories. And when I realized that we have lost very much of that diversity in modern wheats, and then even more so when we get down to the flour itself, what we do primarily with these wheats, at least for human consumption, I realized that there's an incredible history to tap into. This is our first crop. We've been growing wheat for 10,000 years. They're at the archive in Aberdeen, Idaho, the USDA Wheat Archive, which is kind of the well, it's an amazing resource that's public, by the way. Anybody can go in there and online and order examples of little tiny samples, like 50 grams of all these different wheat varieties that they list and catalog. There are 10,000 different named wheats supposedly within that catalog. And they just fascinate me. Capay Valley here is very much a Mediterranean climate. We're obviously going through some significant changes in terms of rainfall and heat. It's about, by the way, if I'm sweating, it's because it's around 100 degrees at least sitting here in my truck at the moment. It's 102 yesterday. Anyway, wheats that are designed to yield well in the Midwest are not necessarily adapted to what grows well here in Capay Valley. I'm fascinated by Mediterranean wheats and particularly Italian wheats because the climates are so similar. And I look at the other crops grown around here, which are primarily nut trees, olives, grapes, that kind of thing. And yeah, it's kind of a sandbox to play in. I'm growing out 10 or so varieties of historical Italian wheats with the help of UC Davis, a couple of some of the postdocs there who've been incredibly generous with their time and acreage and have been working with me for some years now to increase this little sample that we got from Aberdeen into, they had our first face-to-face field day in some years last week. And I just wandered through these interesting stands of historical heirloom Italian wheats. They certainly did not stand up to the modern wheats in terms of yield and disease resistance, but they had a lot of character. And just to see them, I'll have enough to finally bake with them after 5 or 6 years of growing them out now. And it's really exciting. One of them, for example, is called Timilia. They trace that back, and genetically, they can trace that back to the Greeks coming over to Sicily over 2,000 years ago. And that's just that's a line that's really satisfying to tap into. And I think it brings a whole different dimension of what is food? As we're saying, food is culture. And we're tapping into a cultural attribute of that history that I find adds, what's my favorite loaf of bread? I don't know. Loaf of bread made with Timilia that's 2,000 years old. That's part of the flavor for me. It's part of the experience for me. And it's part of the experience for my customers as well.
David, we're going to ask you the third question, and then we'll go right into Q&A from the audience. I see we already have a hand up, but we just wanted to give you a moment to, obviously there's a lot to talk about, but if you had any top of mind thoughts or experience about wildfires and wheat production in California that you feel comfortable sharing, it's obviously
I'll share it all. I mean, my first experience was, I think, 4 years ago now, around this exact same time of year. And I was at, as usual, on a Saturday at the Ferry Plaza Farmers Market in San Francisco. And I got a call from my landlord. I rent the property that where I live. I got a call from my landlord, very distressed, saying, "David, I think the house is gone." And I said, "What do you mean the house is gone?" And he said, "There's fire came down the canyon." I'm literally the first house in Capay Valley on the north end of the valley. So anything that comes down Cache Creek Canyon, which is kind of a wind tunnel, will hit my place first. And wasn't much I could do about it. So I it was the end of the market. I hustled on back, tried not to get too disturbed by things. When I got back home, I found what seemed like half of CAL FIRE in my backyard, including, monster bulldozers and trucks and firefighters and, all their rig with hoses spraying everything down and curls of smoke going up from what used to be my tractor and my forklift and a bunch of things. My house is maybe 100 yards from where I park all my equipment. So it got very close. I mean, they did an amazing job of making sure the house didn't burn. Luckily as well, while I lost a bunch of equipment, none of the fields, I take that back. I got some scorching on my fields at the house. I have a couple of small 2 acres that I plant for seed crop. A little bit of scorching, but it wasn't bad. clearly the smoke had roared through. In fact, I've got pictures you can barely see. I could barely see what was going on. It was really, as you'd imagine, difficult to breathe. In fact, everybody left the valley because the air quality was so bad. And then the same thing happened 2 years subsequent. This is now the new reality here, to the point where I need to seriously question, if it happens again this year, whether I want to continue to try to live and make a living in this kind of environment where fire is a fact of life, the way summer heat is and the way that winter rain is. Last year, in fact, or 2 years ago, my neighbors surrounding me is a Full Belly Farm, very well-known organic farm up here. And they grow their own and mill their own grain, beautiful grain, and they do grow Italian varietals. Anyway, they had recently planted some larger fields just north of my place, and those all burned 2 years ago. And it was tragic to see, but they've got it planted again this year, and very interesting to see, what they've planted and how it's been growing. I haven't talked to Paul Mahler, who's kind of the lead partner there on the planting, but be interested to see what his experience has been.
Yeah, thank you for sharing that, David. It's an intense story, and we wanted to open up to Q&A. There was a hand up. I don't know if it's still there, and people can also type in their questions. But I was realizing with the order of those questions, we may have done a disservice, because of course there's a lot of tragedy and trouble ahead, but also I think we want to be able to celebrate the sort of fascinating work you're doing. So any questions about wheat biodiversity or grass biodiversity, what it is to mill grains, the future of climate change in wheat, all are valuable at this moment. So either put your hand up, or your digital hand, or write in the questions and comments. We'll give people a
I'll
moment
let you
to
field these, Zach, since I'm not sure. Rogue broad, unleavened breads. Just may make a side note, and I'm eager to catch up with Rob offline, because my former life, I worked in indoor air quality and biomass stove design. I was an industrial designer. And so smoke, again, we were trying to eliminate it from indoor situations for cooking. But the microbiology of that is really interesting.
Pamela asks,
perfect. Go for it.
Did you harvest the fields that was somewhat scorched, and did the grain have a different taste?
Good question. Yeah, you could definitely smell it. Those little fields, as I said, I grow for seed. So I just replanted that. I didn't mill or bake with any of that, but we did mill grain grown elsewhere in the valley, which was the whole valley was filled with smoke at that time and in the years subsequent. It's a very good question. I like the lab in Portland, I stick my nose in my grain a lot as well. You can learn an amazing amount about harvested grain by the smell and look, and it's definitely an art as well as a science of grading wheat. I didn't notice anything untowards. I didn't have feedback from customers. And as I said, I work with both artisan bakers doing primarily bread, but I also work with quite a few pastry chefs in some very well-known restaurants in the Bay Area and Sacramento, and nobody commented on it. But it does make me think of, freekeh, if people know the green wheat from the Middle East, which is intentionally burned to remove the hull. These are generally non-free threshing grains, ancient grains, and freekeh was a way to do that. But they're burned and then dehulled while the grain is still somewhat green. And clearly that has an amazing aroma. I've been buying some freekeh that I believe comes from the Palestinian territories, and just sticking your nose in the bag has been really interesting. But freekeh I don't make into bread. You know, I cook that as a grain, as a cooked grain, and it's certainly the smoke flavor is intrinsically part of the food.
Maybe I'll ask you one more question, because then we want to move to some other topics. But I was wondering if there was a grain not related to wheat that you maybe less people have heard about, that you mill or want to draw our attention to. As folks are thinking about expanding their palates and looking elsewhere.
Absolutely. And this came up last week, which I was really happy to hear at the Davis Field Day, which is pretty industry focused. I was excited to hear and see some research they're doing into different grains. Yeah, I mean, wheat's the tip of the iceberg in some ways. You know, there are certainly wheat, well, being very drought tolerant in general. Sorghums and millets, there's an incredible diversity, even more diversity there, a good deal more drought tolerance. Nutritionally, they're quite different. Obviously, gluten is, the proteins in there are very different. I've been milling teff, which has been also very interesting. And teff is a grass, it's poaceae, so even a little more, so's millet and sorghum, but teff is is this grain that is endemic to or indigenous to East Africa. It's what goes into injera, traditionally the flatbread of Ethiopia. It's a staple there, and incredibly drought tolerant. What I find ironically humorous is that all these alternative, we actually grow here in California, we grow quite a bit of these alternative grains, but it all goes to feed livestock. And that's primarily because of the nutritional qualities of them. Teff, for example, is one of the few grains that has a high iron content. Grains don't normally provide much iron, and teff is different that way. I think because the grain is so tiny, the proportion of bran, you know, the outer layer of the grain kernel, which is infinitesimal, is much higher to the starch that compared to, say, wheat or rye or any more traditional grains. Teff, this teff I'm growing, it normally grows at a higher altitude, so it's had to be bred to produce, you know, decent yields at a lower altitude. And there's an Ethiopian agronomist in the area who's been doing that. He's not aligned with Davis formally, but he's in the area. And the teff that I'm milling was the first grown. It's grown in wheatland, strangely enough, a little area north of Sacramento on the east side of the Sacramento Valley, and it's really neat. So I feel, you know, part of my role as a miller primarily is to introduce these alternative wheat alternatives, not as gluten-free, just it's diversity. You know, these are other grains that have flavor, value, and character, and really unique and valuable agronomic qualities. You know, my job is to introduce that to the wider public and to the bakers I work with. I'm the middleman there between the producer, the farmer, and the end user, who's the baker, who, you know, they're the ones that really got to make something nice out of these that people are going to want to consume. So yeah, there's a ton out there. Yeah.
David, thank you so much, and we're very happy for you to stay on. But given the heat in the car and you know where you are, if you have to drop off, of course, that's fine. If you want to leave any questions,
I'm interested to listen, and I want to hear.
Okay,
I want to hear.
Great. So I'm so happy
Natalie.
that Jennifer connected us through your milled wheat. So that was the perfect middleman connection. But we're going to turn our attention just here to Wildfire for a little bit. Emma?
Yeah. So as we've already been discussing, wildfires are becoming more prevalent and severe. Most of us have had some kind of contact or experience with smoke, or at least know somebody who has in the last couple of years. They can even be seen from space. This was a fire that was in Oregon. I think it was 2021. And you could just see the impact is enormous. And then likewise, you can see this picture is of Portland in 2021 with this super hazy sky, and that these wildfires are affecting air quality in nearby locations. And then that also this smoke has been known to spread from one coast of the US all the way to the other coast, and has air quality impacts across even these long distances. And we wanted to just note that although this project is a little bit based in looking at kind of the sourdough and sourdough starters and the science around that, there's also actually, we were told, a really nice exhibition up right now at the Santa Cruz Museum of Art and History. That kind of shows how, you know, wildfires are not just these abstract events or environmental disasters, but they also deeply affect people and communities, like David was also talking about. And that this exhibition kind of shows and tells some of the stories of people who have been personally affected by wildfires in the area. So if anyone has a chance to visit it, we're not there, so unfortunately we can't, but we hope that you can, and to hear some of the voices of people who've been struggling with this over the last years. Let's see. So the artistic kind of research question that we've been exploring is, how do wildfires affect the smell, taste, and texture of sourdough bread? And we've been kind of using this project to explore the complexity of this issue, and make these connections across scale between environment, the human, and then even the microbe. And so we've been trying to obtain a decent amount of smoke tainted wheat from a farm that has been affected, but so far we've only been given very small samples, so not enough to make a whole loaf of bread. And therefore we've been exploring this kind of parallel research path where we're almost prototyping what a future where this wheat is prevalent might look like, by using locally sourced flour and wood chips that could be part of a local wildfire, or would be, to simulate smoke taint in flour using a barbecue grill. And so our resident barbecue smoker, Jennifer, was kind enough to get this Max's Marvel wheat from David, and then spend an afternoon smoking this on her barbecue grill. So we wanted to ask Jennifer the next question, if she's here. Actually, not sure if she has a good connection or not.
Yeah, maybe she could let us know if that's possible to either tell us with her voice or type some notes. Let's see what he says.
I can give, if she's logging, we'll see if she can respond. Oh, there she is in the chat.
So these images are from the second experiment, that Jennifer ran in California, building on Emma, what you did in Portugal. Maybe you could
Yeah, so
what
I went to look up, like, how do you smoke flour? Turns out there's like not that many YouTube videos about that. So using some kind of different techniques for smoking fish or vegetables or whatever, we kind of developed a way of basically placing a bunch of flour on the grill, and using I used eucalyptus wood, but Jennifer used oak because that's more local to her area, where here in Portugal eucalyptus is a huge fire issue. And then, you know, having this kind of right balance of water, charcoal, and the chips to create smoke, and then basically kind of releasing that smoke within the grill on your flour. And so it's a slow process. And actually, I was saying the other day, it's funny, after I did the smoking, I thought, oh, that didn't work at all. It doesn't smell smoky. And then I went home and the next day I smelled the thing. It was extremely smoky, but your nose adapts so much to being around the smoke that you start to not even notice it. So I thought that was a really interesting thing with this. And Jennifer says she smoked it for about 4 hours.
And we're doing this process because, as Emma mentioned, we have gotten some small samples from farms that have been affected by wildfires, but not in large quantities. But if you want to, we have, I think, an hour and a half talk about the very circuitous path we've taken so far, talking to the USDA and other organizations to try to locate some real samples. So this process of kind of simulating the effect is a way that we can begin to ask questions about taste and flavor with some kind of material food product.
And if anybody knows, or if David, in the future you run into some, I hope it's not your own, I hope it's not anybody's actually, but if you run into some smoke tainted wheat, we're more than happy to take that off your hands to work on some smoky sourdough breads.
And we'll talk at the very end about wine and how sort of wine producers and wine industry is attempting to adapt to this. So I think it may unfortunately be something that the wheat growing industry has to take more seriously, especially David noted the whole grain wheat growing industry, which potentially is even more affected, unfortunately, than highly processed grains. But we're going to turn our attention to starter right now. So maybe I may have 1 or 2 sentence definition.
Yeah, so we then took our Smoky's wheats and turned them into a smoky sourdough starter. So basically a starter is made by mixing flour, water, and then environmental microbes and allowing the mixture to ferment for about a week, adding a little bit of flour each day or every other day. And the starter is important in bread making, or in this kind of bread making, because it leavens and flavors bread.
So this might be a question for Natalie, who helped sort of conduct our second Wildfire Loaf experiment over the last week. So I don't know if we have a picture of the 2 loaves here. No, but yeah, Natalie, did you kind of had a control bread, which was made from David's milled wheat, and then one that was made from David's milled wheat, which was then smoked by Jennifer and made as a starter by you. So maybe you can tell us about the differences between those 2 loaves, if any.
Yeah, I think one main difference that I noticed at first was the non-smoked flour had a very strong smell to it. It was much stronger than the fire smell, actually, which I wasn't expecting. But I think it was just because of all the fermenting, I think was more prominent in the original loaf. And the fire starter kind of it did smell very smoky, but also smelled very dense, as like, I know this is maybe a strange thing to imagine, but like I imagine like smoke being very dense and kind of like settling on things. And so it had that kind of like neural pathway feeling of like, oh, this is even though I can't feel it, when I smelled it, it smelled very dense and not so much as acidic-y or acidic-y or vinegary as the first one. But then later on, I think the starters kind of started blending in. I mean, once I started putting in the flour and the salt and everything, they kind of stopped smelling different. So the only way I was able to taste or smell the difference later on was when they actually had been baked. So definitely at first it was the most, or when they were still in their feeding process was when I could smell the difference the most. And then of course, after the baking.
Nice. And this is one tool that we've been using in some of these projects that comes, it's a collaboration between the Dunn lab at NC State and tasteforlife.org, which has just sort of a lovely selection of English adjectives that can help us be more precise about the things that we think we're smelling when we are smelling sourdough starters. So it's a lovely tool. We highly recommend people use it. And then actually we're gonna go to Rob. Do scientists still really rely on their noses, and what can be learned by smelling a sourdough starter? Because that was one of the things that always fascinated us about your work, that people kind of weren't just using digital tools, but yeah, we're using their bodies.
Yeah, so super interesting question. So I guess I'll answer it in layers. The short answer is yes, that noses are still better at distinguishing food-based aromas than our technical measurements thereof. I mean, often the best combination is actually characterizing which lightweight chemicals are coming off of a bread and then which things we're smelling, and you can couple those, which we've done, but it's still very common to rely on smelling a sourdough starter, smelling a tomato in order to figure out which chemicals detectable by human noses are present. And there tend to be two ways that you can do this. One is more relevant to the average consumer. So you can just bring in people with very little experience in smelling a food, and you have them assess the smells of the food based on an aroma wheel or something along these lines. And if you're trying to sell a food, that's actually the most relevant measure of what aromas it has. The other thing that you can do is you take expert sniffers, people who are trained to distinguish the aromas of different wines, different cheeses, or different breads. And there are expert bread panel sniffers, expert panels of bread sniffers around the world. And they tend to be better able to distinguish subtle differences. And part of what's going on here is that smell is very unlike taste. I should back up a little bit. So we smell in two ways. We smell when we sniff things. And so if you put something in front of your face, that's called orthonasal smell or orthonasal olfaction. But humans are pretty unique in that we also feature smell in our mouths. That's called retronasal olfaction. And those two things can be very separate. So how you think about something you sniff versus how you think about something that you appreciate from the smells that go through your mouth and up into the back of your nose. And because of the flatness of our heads, because we're upright, we actually feature those retronasal aromas more so than most other species do. And so when we're experiencing retronasal aromas, they're part of flavor, part of the second kind of smelling. But flavor also includes taste. But these two systems are really different. Taste is really innate, it's instinctual, sweet is sweet, sour is sour, umami is umami. Smells are not like that. Smells are entirely learned. And so your brain needs to learn to categorize different sets of aromas. And so when people are becoming experts at smelling, their brains are actually creating more categories for more kinds of aromas. But they're also giving what's called a valence to those aromas. They're assigning them as either good or bad. And that's totally learned. As far as we understand in humans, there are no instinctually good smells or bad smells. All smells are learned to be either good or bad. And that starts in utero and continues to happen through life. And so it's because of all this complexity, and this then as a result of that learning, it means that different cultures think of the same smells in different ways. And so if you take the same bread to northern Italy and southern Italy, how people perceive that bread will be totally different. And so when you say what can be learned by smelling a sourdough, the answer is going to be different depending on who is smelling the sourdough. But the short answer is yes, scientists still rely on their noses. Our noses are very important. And there's all this subtlety that they're picking up on that our instruments still often miss.
Thank you. That was great. We have a question that David's asked about what your expectations of the Wildfire Loaf experiment we told you about. We'll hold on to that for a second because we just want to get some larger overview, Rob, from yourself about your general research and your research on sourdough. So yeah, I was so happy we ran into you so many years ago, because why research sourdough starters at all? And yeah, what are you interested in general? Why is it important?
Well, so I'm interested in them partially because they're the interface between all these interesting ecological and evolutionary things in our daily lives. And so they're a way to think about the same ecological rules that happen in a rainforest or in a grassland, but they're happening in our bread. And so from the perspective of showing the value of science to our daily lives, they're really interesting. But the other reason I'm interested in them is that they've been neglected. And part of the reason they've been neglected, especially in the US, is that when we started food science departments, those academic departments really became focused on industrial foods. And so how do you think about scaling up production of breads? How do you make, jam production when you're making 1 million jars of jam safe? And to the extent that anybody worked on foods people made at home, the focus was almost entirely on the safety of those foods. And so that meant that all of these foods that are mostly made at home and not commercialized as much, they just haven't been studied. And so sourdough starters are one of those things. They've been studied a little bit in Italy, a little bit in France, and they're starting to pick up. But when we started to do this work, there were just really simple things about sourdough starters we didn't know. And so, for example, the classic story of sourdough starters is that they have 2 lactobacillus species, typically, bacteria that make them acidic. Okay, I'll answer this question as I'm moving through this. Yep. And they have a yeast. And the yeast is what produces the CO2 in the starter and makes the bread rise. The lactic acid from the lactic acid bacteria makes it acidic. And the combination of those 3 species is what then also engenders the particular flavors and including the aromas of the bread. What we figured out in this global sourdough project that was led by a group of amazing students and postdocs was that globally there were hundreds and probably thousands of species in sourdough starters, and that the average sourdough starter has multiple species of yeast and tens of species of bacteria, and subtle differences in the bacteria and yeast from one starter to another have big effects on the flavor. And so we didn't know that. It seems like a really basic thing to know about a food that people eat every day, an ancestral food, a food we've been eating for thousands of years. And so that's part of why to study it too. And so to go to the second question then, which I think is the third, but what have you learned about sourdough starter microbiome diversity so far? Very diverse. Several surprises. So one is that if you talk to people who make sourdough in San Francisco, for example, they'll tell you that the bacteria in San Francisco for sourdough making are very special. You can't find them anywhere else. And so that's why a loaf of bread in San Francisco should cost $40. In truth, what we found, because of the hetchy water, in truth, that's bullshit. The Lactobacillus sanfrancensis, it's characteristic of San Francisco, is actually not any more common in San Francisco than it is in Belgium or Australia. And it's actually more common in some places than it is in San Francisco. And so there's actually almost no biogeographic effect on the bacteria in a starter, as far as we've studied so far. It may be that, if we go more to the tropics, it becomes different. But for the most part, you can get the same basic kinds of bacteria almost anywhere in the world. The yeasts are more isolated and more different from place to place, but still not in that clear way that San Francisco story would suggest us, lead us to believe. The other surprise is that there are, it could be that there's some effect of the hetchy water that we've not yet identified and yet contributes some subtle magic that is as of yet missed in our story. I will leave that open. But the other thing that was a surprise is that a common yeast in sourdough bread and non-sourdough bread and beer is Saccharomyces cerevisiae. And there are a number of surprises about this yeast. First, and this didn't come from us, but from other people, it's now clear that this yeast originally comes from China. its natural history is that it rides in wasps from sugar source to sugar source. When the wasps put it in the sugar accidentally, it then metabolizes that sugar, then attracting more wasps, and it catches more of a ride. And at some very early point, this was co-opted before agriculture by people who wanted to get drunk. And so that's a surprise. And it's a surprise too that both bread and beer are now clearly before agriculture. And so the strong indication is that bread and beer, that we started to farm in part because we wanted more bread and beer. Now very well supported idea. So that's kind of surprising. The other thing that was surprising is that if you talk to industry people, what they would tell you is that if we looked at Saccharomyces cerevisiae and sourdough bread around the world, that would always be the same one. That it would very often be this sort of industrialized sourdough that's escaped, this Saccharomyces that's escaped. What Katie Heil has recently shown is that different sourdoughs in different places have wildly different Saccharomyces cerevisiae, that some of which produce acid on their own, some of which don't, some of which are fast, some of which are slow. And so there's this hidden diversity even within a species in the sourdough. The other thing, I'm trying to figure out what your next question is going to be so I can anticipate, but I'll start answering now. And yes, okay, so I'll segue. The other thing we've been able to show, so the other question that's interesting to us is, where do the microbes in the sourdough starter come from? And there's a Korean term, somat, which means hand flavor, that is the flavor that the person that makes a food gives to the food. And so there's a question in Korean culture about how literally should one take this. But we began to become interested, could we take this quite literally? Is the person making, especially fermented foods, actually contributing microbes to the food that affect their flavor? We wanted to study this in kimchi. Kimchi is too difficult, wasn't a good place to start. We started to study this in sourdough. We had bakers from around the world, professional bakers, come to Parato Center for Bread Flavor in Belgium, and we had them make starters with the same ingredients, and what varied was their bakery and their hands. And we were able to show that the subtle differences in the microbes in their hands led to differences in the starter composition, because their hand microbes were going into the starter that we could ultimately detect in the flavor. And I'll go from that to the wildfire in 2 sentences. But the other piece of this that we didn't anticipate is that the hands of the bakers were super weird. So if you look at the average person's hands, they're about 3% lactobacillus bacteria and no percent bread yeast. The bakers had up to 70% lactobacillus bacteria and 70% bread yeast for bacteria and fungi respectively. And so it looks like the act of working with the sourdough is changing them. And so there's this intimacy between body and bread that's really quite deep. And I think it's true for many fermented foods, and I can go into that more later. It's true of yogurt, true of chicha, true of other things. So what would I expect, or what interests you about the wildfire loaf? What interests me about the wildfire loaf? To me, I think we often struggle to think about the direct connections between the changing world and our daily lives. And so I think the idea that there is flavor from the wildfires globally, these fires that ultimately stem, most of them from climate change, that stem from our burning of fossil fuels, that is sneaking into our daily lives and influencing what we taste every day, is fascinating to me, and is a connection that if it's present, sort of raises up this bigger story of our relationship to nature and the way in which it's connected around the world, to the field, to the fire, to the bread, to our mouths. And so I'm fascinated by this idea. And this is an idea that the Center for Genomic Gastronomy has really, become the world experts in thinking about and exploring. And so I'm also just fascinated in this longer conversation. What do I expect? So we know that the subtle chemical differences in different grains can have big effects on the microbes that are present in sourdough starters. And so I don't know if the chemical effects of the fire will have an effect on the microbe and then on the flavor, but it's plausible. And so I do expect that there will be differences in the microbes due to the fires. I do expect that those will ultimately be detectable if we have a big enough sample. What I don't know yet, although I'm hearing feedback already that suggests an answer, is if you just hold up 2 loaves of bread, can you then in that moment detect the difference? Or do you need to be trained to detect that difference that may be present there? So I'm really interested to continue to explore this and to continue to learn what this answer looks like. And I love the provocation, and I'll pause here. I think this is my last question. Is that right? Zach?
Yeah, official.
And for me, I love the provocation that art offers in this context. You know, this is something that we could study scientifically, but this partnership between art and science allows us to sort of consider this provocative question of how global tragedies make their way into what we taste and smell in our daily experience. And so I'm very grateful to be part of this conversation, because I think it's one that we need art for. We need art to help us push.
Thank you very much, Rob, both for your answers and the kind words about our work. And yeah, now we actually have a moment here for Q&A. If there's any questions for any of our guests so far or the artists themselves, do give us a shout. And let me see if we've answered David's questions actually for Rob. Yes. I think, Rob, how does smoke impact wild yeast? I guess we only have evidence so far, I guess, Rob, of 2 of these sort of citizen science experiments, but we have this protocol now that we're developing. But I think both times the smoked wheat had a lot less fermentation and smelled less sour. And so that's sort of something we'll have to dig into further. But I guess my hypothesis there, or just thought, was that, oh, this more smoky environment is not inviting in as many or the same population of, sour smelling microbes.
Yeah, I mean, one thing I hadn't thought about till this conversation is that the other possibility is that the smoke is killing insects. And so nobody knows where lactic acid bacteria live in nature, which is fascinating. I mean, they do occur in insects. Is that the main story? We don't know yet. So we don't actually understand very well how and when they arrive on grain and when they don't. But it could be that a fire burned and smoky grain ends up with less insect exposure. And so in that context ends up with fewer opportunities for colonization of the right microbes. And it could also be that the possibility that the right microbes are on the grain is really a little bit stochastic, it's chancy. And so if the smoke is killing some of them, it just could be just enough to reduce the probability that you get the right microbes in the mix. And so I guess I would ask you, go ahead, please.
No, I was just going to say the insect thing is something we haven't considered at all yet. And I really, when I made the smoky sourdough starter, I was really surprised by how it smelled really like vomit. Like really like vomit in a way that none of the other sourdough starters I had ever made smelled like. And so I was like, there's something going on here that's either something's missing or some microbe was kind of winning over and dominating the others. And in the end, it kind of evened out. Like it stopped, the vomit smell went away. But for the first like 4 or 5 days, it was, yeah.
Yeah, so the vomit smell is usually because the lactic acid bacteria haven't taken over yet. And so that would be an indication that they're not there yet in force. And so maybe are then coming from somewhere else and setting up.
Yeah.
Natalie has her hand up.
Oh yeah, I just want to throw in there. I think it's really interesting about this like permeability between like the air and then also between like yeast and yogurt and stuff, and how our body kind of exchanges like endorphins and like information and like microbes and stuff between these kind of non-tangible spaces, but then also tangible things like wheat. But then I was remembering a conversation that I had with someone about how the smoke in the air can actually travel through our pores, so through our skin, and then become kind of lodged, or maybe not entirely, but there's something that happens between the porosity of water intake as well, and then water outtake when smoke comes through the air. So yeah, I just thought that was really interesting, because it's something that I guess is just becoming more of a thought, especially with pollution, like car pollution, and obviously the rising wildfires here in California. And yeah, definitely, I think we're doing a toxic exchange. Our bodies are at least doing a semi maybe toxic exchange, or taking in that toxicity from the air.
Yeah, I mean, I guess, so it's a very interesting point. And there's a little feminist theory on here about leaky bodies and permeable bodies that draws this in. I mean, one thing for sure we know is that in general, if you look at the composition of a human body and its associated microbes, it reflects its exposures. And so, you know, American bodies are 60 to 70% of the carbon in American bodies from corn. But also the microbes that are on your body and in your body reflect your exposures. And more often in the US, your lack of exposures. You know, we're losing all kinds of key microbes generation after generation. And then, as you point out, Natalie, all of these chemical exposures, some become embedded in our bodies in different ways. And so it's, I mean, I often think about like, well, what story do you want the chemistry and microbiology of your body to tell about the life you lived? Because it's telling a story whether you read that story or not. Yeah, great point.
We are getting close to the end and we have a few more slides to go through, but I have to, you try to ask a question about the bakers again. It seems like their skin microbiome changed significantly. Have you or anyone else looked into, the larger impacts on health or happiness? Should we be distributing, getting back to all doing a bit of baking to sort of seed our bodies with nice things?
Well, I'll tell you what we know, which is a thin layer. So Justin and Erica Sonnenberg at Stanford have done amazing work where first of all, they've shown that Western bodies are missing most of the microbes we would have had 200 years ago. Like we're just a microbial shell of what we used to be. And that results in all sorts of health problems. We don't have a good way of restoring them. Nobody's studied, as far as I know, ours is maybe the only study of the effects of a specific lifestyle on skin microbes. We're trying to do more, but for whatever reason, that's pretty open. We do know that there are benefits to eating fermented foods on gut health. It was initially thought those fermented foods were restoring particular species to the gut. Instead, it looks like more like something about those fermented foods just helps to favor some of the rarer and more important microbes that are already there. And so there's a good study recently that shows that, again, by Justin and Erica, that if you eat fermented foods with lactic acid and fermented foods with acetic acid, that there are these pretty conspicuous health benefits quite quickly on gut health. And so somehow that's helping the microbiome. It's not restoring it. It's like making an urban field slightly more biodiverse, beautiful, and functional, but it's not turning it into an ancient grassland. And so this will be a huge area for research in the next years because the rate at which we're losing these species has accelerated. A new study came out this year or last year showing that the key microbe that babies use to digest breast milk is being lost in the US. And part of that is C-section births and the and formula feeding, which is not to put pressure on moms. Both those things need to happen in many cases. But that's not the whole story, and we still don't understand it. But it's a super functionally important microbe, and it's declining year after year. And so there's a lot going on here. I'm rambling now. Sorry.
No, it's great. We can turn our attention really quickly to two fermented foods, sourdough bread and wine, although you should definitely go beyond those. And then we'll see if there's some final tasting notes to round out the night. Yes.
Yeah, actually, do we want to go right to the wine?
Maybe,
and then we'll
Natalie,
just
tell us about these images really quick, so we can see if they'll work. Yeah.
Just really quickly, yeah, I didn't catch the rest of the sentence on the other slide. But yeah, I was really curious because the first loaf that I made, the controlled one, rose very quickly and was very bubbly. And I was very worried about the fire one because it hadn't risen at all overnight. So there's a lot of ad hoc, like last minute methods. I like left it out for an extra couple of hours in a warmer environment to see if it could rise, as well as throwing in a little bit of all-purpose enriched flour for the first control starter because I ended up running out of some of the flour. That was my mistake because I tried to make a third starter, which I thought I'd make a third bread with for the tasting, but that didn't end up happening. So I threw in a little bit of that flour into the control one, but then left the fire one completely with its original bread. And I don't know what happened. The thicker loaf ended up rising a lot more. I mean, maybe it was something with the last minute technique, like the starter loaf or the control loaf was very, very flimsy. Even though it had risen, I had a hard time keeping it in shape. No matter how many tidbits of flour I was throwing onto it, it would just not fold. So I think maybe with the fire loaf, I had a little bit of an easier time molding it as well because it had a thicker consistency, even though it wasn't as airy and it was kind of drying out really fast. So I was adding like water to it and then trying to fold it over where it was cracking, and then kind of at the end it allowed me to shape it. So I'm really grateful for it allowing me to do that. And yeah, that's pretty much it. They turned out, I mean, this is my first time baking bread ever, so I was really nervous. I got like those first time jitters, but I think with the idea of the experimentation, with the idea of kind of trying to figure out the technique and the folding and taking away flour, putting in more flour for the environment that it was in, because obviously it might have been different where I was in Corralitos versus where the recipe was made, or the printed out recipe. So yeah.
They look incredible for a first time baking. I mean, I think, yeah, I would not have come out.
I'm pretty proud.
Yeah, I think we just want to say a quick word about wine, because it is the part of maybe the food industry that sort of started to address wildfires more directly, and then we'll be close to the end and learn about the tastings. Is that right?
Yep. Yeah, so unfortunately, Professor Philip Cruz couldn't join us today. So we've kind of tried to summarize some of what we wanted to ask him about from what we can, could read online, but hopefully in the future he can join us and inform us more than we're going to right now. But essentially there's very little research about the interaction between wildfires and wheat producing landscapes, but the wine industry and government and university partners have been researching and adapting to these new conditions in quite a serious way. So like we mentioned before, it's either about moving to different geographic locations or different fire prevention strategies, or then also trying to process wine or process grapes into a way that makes a drinkable wine. And the work that Professor Philip Cruz from UCSC was doing is actually more about how to identify smoke taint in wine. But first we'll show this You can go to the next one there, Zach. It's this is a wine from a producer in Portland, Oregon that actually they've experimented with different processes for making smoke tainted grapes into wine, and even trying to kind of use that as part of the story and use a little bit of a smoky flavor as an enticing thing rather than a disgusting thing. So a little bit like Rob was talking about how taste is kind of a developed, learned, and can be quite cultural. And so the way they describe their wine making process is white grapes went straight into the press. The free run juice was separated from the press juice. The press fractions from each of the white grapes were blended together to co-ferment. Red grapes had 2 to 3 days carbonic maceration. Fermentations were super fast this year, and after 2 to 3 days, they were pressed. And the press fractions from the reds were blended with the press fractions from the whites, all finishing fermentation together. All free run was put aside. Wines were racked off the lees 4 times to prevent some of the ashy quality of smoke taint, and gives the wines a fresher, brighter, juicier quality. So yeah,
I thought that was just
and
some
then
nice poetry from the technical side. Who was like reading those processes out?
And then to look a little bit at what they were doing in terms of researching the smoke taint and how to identify it, Professor Cruz and colleagues at UCSC were looking at how to use analytical data to help decipher which wines or grapes were affected by smoke. And the research uncovered these kind of biomarkers or specific compounds that make it easier to identify the smoke taint and that hadn't been really identified beforehand. So one of the main issues previously was that markers became undetectable because they were binding with sugars in the grapes, and the smoke taint basically wasn't detectable at all until it came in contact with the enzymes in our saliva, which released the bad taste. So basically they didn't really know that the wine was bad until people were actually drinking it. So this is kind of, again, new research that is becoming more and more prevalent because of the severity and likeliness of wildfires. And so we hope we can continue the conversation about wheat parallel with the wine industry. That seems like a little bit like a step ahead of the wheat industry.
And then this is the form that we've previously designed. Natalie's holding up her copy for this sort of experiment where we're comparing 2 loaves and trying to sort of see some of the, evaluate some of the differences. And I don't know, Natalie, if you had a chance to grab any of those notes that you wanted to share with us here, or?
Yes, I'd love to. I had kind of everyone, for the fire loaf, I had everyone put their own little markings underneath there, underneath the questions. So for the fire loaf, for touch, I had a lot of soft, I had a firm, and then I had some bright-ins. I had a squishy, and then I had dense, and I had doughy. For the aroma, which I thought was the most interesting because everyone kind of smelled the same thing, or maybe it was once one person said what it was, everyone's like, oh yeah, that's what it smells like. But a lot of people got smoked salmon because of this kind of dense, thick like smell, which was really good. And a lot of kind of, so like fishy smells, there's seaweed smells. I smelled potato for a second. Someone put dust. Someone else just put smoky, someone got salty, and then someone put the moment you open smoked salmon. And the taste, so aroma versus taste now. So what do you smell versus what flavors do you taste? People tasted fish again, smoke, yeast, heaviness, chowder, more yeast, beer, meat, barbecue, and more seaweed. So that was really great. I feel like there's a meaty component, a salmony meaty component to it, which was pretty intense, or something that reminded us of the barbecue.
Yes.
Yeah. And then for the mouthfeel, what do you feel? We got mostly gummy, soft and moist. We got one that was gritty. The salivation spectrum. So when we were taking another bite of the sample and marking our salivation, which is kind of hard, but I think we agreed to do it between no change and drooling. So like kind of in between the two. And then satisfaction, everyone wrote delicious. All their X's were by the delicious mark. So again, proud of that. And then for visions, what do you imagine? Taste can take us places. Did tasting the sample today bring any visual imagery, imaginings, or memories to mind? If so, describe them below. I wrote again, smoked salmon, like on a lox bagel. Someone wrote foghorn. Someone else wrote family and barbecue. Someone else wrote picnics in the grass. Someone wrote their brother's house. And then, someone else wrote early COVID, which was really sad. And that's kind of the final farewell of the evaluation, the tiny COVID remark. Yeah.
Thank you. Yeah, thank you so much for running the experiment from top to bottom. It's a lot of work. And I guess in terms of the very informal data we're collecting thus far, it's fascinating to see all of the fish kind of components. So it's curious to imagine, because we didn't get to taste or smell it yet, if something happened in the fermentation process that drew those out, because there did seem to be some coalescing around that. So that's super interesting. Thank you very much.
Sure. Mm-hmm.
Some more pictures of the tasting.
Oh, yeah.
And I know we're just at time, so we're happy to field maybe one question for sure if folks still have one. And while people maybe are thinking what that is, we'd like to thank all of our guests. We definitely leaned on a lot of people to help us out. Rob and David with some of their expertise, and Natalie with all your hard work. And Jennifer, thank you so much for inviting us to be artists in residence for this year-long From Afar, and for Smoky the Wheat, which was very important.
It really takes a whole campus to host a virtual residency to help pick up the slack when we can't be there in person. So it's been really amazing collaborating this year.
Great. Well, thank you very much. For those that want to hang around, Emma and I will stay on a bit, but I think Louise will maybe end the official part of the talk.
Yeah, thank you everyone for tuning in, and thank you Emma and Zach for leading us in this very interesting discussion. I was really happy to hear from David, Rob, and Natalie. So I invite you all to stay in touch. This series continues through the fall. We don't have the date just yet, but it'll be during the fall quarter when the academic year begins again. So please keep in touch. Check our website, sesnon.ucsc.edu, for upcoming events. And again, this event has been recorded and will be on the Sesnon Gallery YouTube channel in about a day or so. So thank you again.